in DAISY format. You can navigate to any chapter or any page by using arrow keys, provided you have DAISY software and device.
CIET NCERT presents the audiobook History of Kasturba Gandhi Balika Vidyalaya Bridge Course for Girls Entering Upper Primary Stage. Page 1, Chapter 1, Introduction.
इतिहास वो नहीं कहानी जिसमें केवल राजा रानी, उनका जीवन, उनका राज, उनकी सेना, उनके काज, जीत किसी की हार, रथ, घोड़े, हाथी, तलवार, मंत्रियों और मुलाजिमों से सजा हुआ दरबार, महलों का और युद्धों का ही नहीं है ब्यौरा इसमें आज, आम लोगों की भी इसमें गूंज रही है अब आवाज। आम लोग तब क्या करते थे? आम लोग तब क्या करते थे, कैसे करते गुजर बसर? युद्धों और हार जीतों का उन पर पड़ता क्या असर? महिलाएं तब क्या करती थीं? महिलाएं तब क्या करती थीं और बच्चे क्या करते थे? इतिहास के सब कालों में वो सभी तो बसते थे। सबका जीवन, सबकी शैली, लोक कला और तीज त्योहार, सबका जीवन, सबकी शैली, लोक कला और तीज त्योहार। इतिहास में आज सभी हैं, नहीं खास कोई, न है आम। हां, इतिहास में आज सभी हैं, नहीं खास कोई, न है आम।
The bridge course in history is designed to give girls a glimpse of India's multiple past. It gives an idea as to how human beings tried to understand their natural and social environment and changed their lives from simple living to a more complex one. That is, from meeting needs of food, clothing, and shelter to needs of entertainment, employment, etc. There was a constant effort to understand the mysteries of nature for the purpose of survival. Humans learned to protect, produce, preserve, and conserve. This led to a more settled life. The themes in the bridge course are designed to help girls understand the journey of how humans began their life on Earth. Some discoveries and inventions which tried to revolutionize human life and the gradual development of early cities is mentioned in the present course book. It also discusses how from time to time people entered the porous boundaries of what was India in the past and made it their homes. The impact of interaction and intermingling of local and non-local population is evident even today. The impact of such interactions is visible in clothes, food, music, art, and architecture to this day. The last section highlights the contributions of some eminent men and women who address the issues of social inequality and national pride. After studying the bridge course, you will be able to appreciate that we had a multiple past and our cultural heritage was based on the contributions of men and women who belonged to different sections of society. The bridge course in history should not be treated as yet another book. It is a modest attempt for making the study of India's multiple past interesting and interactive. The various activities suggested can make the teaching of history come alive by encouraging girls to draw a link between the present and the past. Activities given in different chapters can be contextualized according to the requirement of each Kasturba Gandhi Balika Vidyalaya located in diverse blocks. The box items in Hindi and the poems can be translated into the local language or changed as per your requirements. क्यों पढ़ें हम इतिहास? इतिहास एक रोमांचक यात्रा है। ये यात्रा तुम्हें समय और संसार की आर पार ले जाती है। आज हम जिस दुनिया में हैं, उसे बनाया है हमसे पहले आए लोगों ने। उनके जीवन के सुख दुख, अपने युग की समस्याओं से जूझने की उनकी कोशिशें, उनकी खोजें और आविष्कार, इन्हीं के ताने बाने में तो मानव समाज बदला। हम लंबे अंतराल में धीमे धीमे होने वाले परिवर्तनों का असर इतिहास के झरोखे से देख पाते हैं। इतिहास पढ़कर हम समझ पाते हैं कि आधुनिक दुनिया अनेक सदियों से हो रहे बदलावों का परिणाम है। पेज 2।
Nervous system. KG Kasturba Gandhi.
Saw everything, didn't we? So what all did you see? What did you understand? If I ask such questions suddenly, you will not be able to answer it. So let's do one thing. Let's revisit the visuals. It is the greedy Kuttapan who still be approaching. Will he ever leave off a ripe mango? The moment he saw it, his mouth watered. Look, he has started to eat it. Hi, what a taste. Look at his face. It speaks volumes of his likeness for the mango. In the third scene, we see a small village plant. It is a touch me not plant, a simple herb. Look, he's trying to scare it with a small stick. Did you notice? He just touched once and the leaves drooped. Oof, the poor touch me not plant. This is Appu's little baby. He hears a sound when he is lying. That is the sound he likes best to hear, his mother's sound. Look how happily he listens to it. Let's look at this scene and discuss further.
So let's go with the questions, right? So to what all have the birds and the children responded? Touch, sound, sight and smell. The objects that can around responses in humans are called stimuli. Various stimuli like hunger and thirst happen inside our body too. Hunger is a stimulus that tells us to have more food. At the same time, thirst is something which urges us to drink more water. These are internal stimuli.
There is a large network of neurons in all parts of the body to receive various external and internal stimuli. The nerve cells coordinate the responses that arise due to the internal and external impulses. Thus, the nervous system helps different parts of the body to communicate by managing and coordinating various impulses. Let us discuss the nerve cell in detail. For this, we have to look into the main parts of the nerve cell.
This is the nerve cell. The outer extensions of the nerve cells are called dendrons. Dendrites are the branches seen at the tips of the dendrons. Did you notice this long extension from the cell body? These long strands are called axons. The branches at the end of the axons are called the axonites. The furthest end of the axonite is the synaptic knob. Did you notice the cells that cover up the axons? These are the Schwann cells.
Now let us look into the functions of the different parts of a neuron. Dendrons carry impulses towards the body through the dendrites. The response impulses are carried away from the body through the axons. Through axonites, they are carried to the synaptic knob which secretes the neurotransmitter.
Let us look into what the myelin sheath is. The myelin sheaths are fatty cells that cover up the axons. As the Schwann cells repeatedly circle up the axons, shiny white colored myelin sheaths are formed. All nerve cells are not covered up by the myelin sheaths. Areas of the brain and the spinal cord which are covered by the myelin sheaths are known as the white matter, and the areas where myelin sheaths are not found in abundance are called as the grey matter. The main functions of the myelin sheath include providing oxygen and other nutritional components to the axons, increasing the speed of the response impulses, working as an electrical insulator and protecting the axons from all possible injuries.
The information transmitted through nerves is the nerve impulse. These nerve impulses are actually electric signals that travel along the axon. There is an electric difference between the inside of the axon and its surroundings. This difference creates a positive charge at the outer end of the plasma membrane and a negative charge in the inner part of the plasma membrane. When excited, the ions are disturbed from their stable state. When such a condition happens, you can see how the positive charge is formed inside the plasma and negative charge is formed outside. These changes do not stay for long. The change that happens in the axon is transmitted to the nearby axons. Thus, similar impulses are created in a particular area. When such an activity is initiated, impulses are transmitted through the axons. The impulses reach the brain and the brain decides on the appropriate response to be generated for the same. For such effective transference of impulses and responses, it is necessary to pass on information from one nerve cell to the other. The role of the synapse. A minute gap between points of contact is important at this point.
Synapses between neurons can either be found between two neurons or between a neuron and a muscle cell or between a neuron and a sensory gland or cell.
Synapses help in regulating the speed and direction of the response impulses. Certain chemicals are generated as part of the electric waves in connection with the excitement of a neuron. These are the nerve vesicles. Vesicles with chemicals move towards the membrane. Chemicals are released and diffuse toward the next cell's plasma membrane. The chemicals open up the transport proteins and allow the signal to pass on to the next cell. Acetylcholine and dopamine are examples of nerve vesicles.
Yes, these are the physical activities that are behind our thoughts or feelings that we feel.
What are nerves? Nerves are a bundle of axons. These are covered up by myelin sheaths. Nerves are divided into three on the basis of their functions: motor neurons, sensory neurons, and mixed neurons. Motor nerves send impulses or signals from the brain and spinal cord to all of the muscles in the body. Sensory nerves send messages from parts of the body, such as skin and muscles, back to the spinal cord and the brain. Mixed nerves control involuntary or semi-voluntary functions and facilitate transmission of impulses into and out of the brain and the spinal cord.
What is the nervous system? Let's look in detail. The nervous system comprises of two parts, the central nervous system and the peripheral nervous system. The brain and the spinal cord together form the central nervous system. The peripheral nervous system consists of 12 pairs of nerves from the brain and 31 pairs of spinal nerves.
Why is the brain the most important part of the body? The brain is the seat of the nervous system of our body. Maximum number of neurons in the human body is present in the brain. Our brain is well protected. It is placed inside a very hard structure called the skull. A layer of membrane called the meninges covers up the brain. The meninges is made up of three connective layers. A special fluid called the cerebrospinal fluid fills the layer between the meninges and the skull. The cerebrospinal fluid is formed from the blood and gets reabsorbed into the blood itself. The cerebrospinal fluid functions to provide adequate oxygen and nutrients to the brain, regulates the pressure within the brain, and also protects the brain from any accidents.
the main difference between the brain and its counterparts and the other organs of the body is that brain is the sole function organ which is controlling each and every tissue of the body. So it has got specific sites inside the brain which will control each and every corresponding part of the body. So in that way it is unique. Means if any damage or any impairment occurs in a structure or function of a particular part of the brain, that will manifest as a defective motor function or defective sensory function or some other autonomic functions of a different part of the body, depending upon the area controlled by that particular damaged zone. That is the main difference of a clinical manifestation of a brain disorder and the disorders of other parts of the body. Now let us come to the main structure as well as function of the brain in brief. The brain is constituted, and its part, the CNS, the central nervous system, as well as the peripheral nervous system, is constituted by the brain and the spinal cord and the nerve complexes arising out of it. And these nerves will divide into individual nerves, and they will be distributed, or they will be supplying each and every organs of the body, including the muscles, the skins, the other structures, the visceral structures like heart, lungs, the intestines, and almost all the tissues in the body is being distributed with these nerve bunches.
What are the various parts of a brain? Cerebrum, cerebellum, thalamus, hypothalamus, and the medulla oblongata are the different parts of the brain that regulate and coordinate the activities of the brain. Spinal cord is the continuation of the medulla oblongata of the brain. It is protected inside a ring-shaped set of bones called the vertebrae. The spinal cord is also cushioned by the meninges. White matter is seen in the outer end of the spinal cord, and grey matter occupies the inner part of the spinal cord. The central canal in the middle of the spinal cord also has the cerebrospinal fluid inside it. Sensory impulses move into the spinal cord through the dorsal root, and the response impulses move out of the spinal cord through the ventral root. The impulses that reach the brain from various parts of the body are all transmitted via the spinal cord. The spinal cord also coordinates and hastens muscular activity like running, jogging, etc.
Did you notice the responses? These responses do not take place consciously. Such involuntary and instant reactions to a stimulus is known as reflex action.
The part of the responses during a reflex action is called as the reflex arc.
Now let us come to some of the common disorders of the nervous system. The commonest that we see among these are epilepsy. So you have met with, or you heard of so many situations where you label it as epilepsy and associated disorders. What is epilepsy? So as I said, the brain is functioning on the chemical as well as electrical basis. Suppose somebody is trying to lift a hand. Before he is planning that, there is some chemical adjustments going on inside the brain cells. You call it as neurons. And these arrangements, or change in the arrangements rather, will induce a sort of chemical energy within that particular nerve. And that will be conducted through the neuraxis into the muscular system, or whichever area that particular nerve is supplying. So that energy, that is that electrical energy, will contribute to the main functional mediator of the nervous system. So this production of the electrical energy is controlled, automatically controlled. And if it is not controlled, that is the amount of the energy, the site of the energy production, and the time of the energy production, that is electrical energy production. If it is not controlled, it is producing unwanted amount in unwanted location. That will manifest as an unwanted motor, sensory, autonomic symptom inside the body. And this is, in brief, what you call it as epilepsy. So there are so many drugs to abnormal production, and the reasons of the abnormal production do vary from patient to patient. You can have some tumors-like things irritating inside the brain, producing the abnormal energy. You can have infections inside. You can have stroke inside. And in many situations, what we face is you can't demonstrate with your available gadgets any of these things, but the patient is manifesting as epileptic. This is just what you call it as primary seizure disorders. You can detect these abnormal electrical discharges through what you call it as electroencephalogram, that is the monitoring or recording of the electrical energy of the brain. Now, second, one of the important diseases which will affect the brain and its connectivity is Parkinson's disease. The defect basically here is abnormal slowness of the normal body movements and some disequilibrium, that is the tendency to fall. So this is the basic manifestation of the disease, what you call as Parkinson's disease. There are different reasons you can have a primary Parkinson's disease. Mainly it is a degenerative disorder of the brain. The chemical which is needed for what you call dopamine, which is needed for the rate as well as the range of and the speed or the body movements is gradually being reduced. That particular cell is going damaged. It is a degenerative damage rather. You can't to that extent revert it back to normal. There are certain medicines which will function as dopamine, and it will fulfill to some extent the deficiency of dopamine. That you can correct the clinical manifestation to some extent, clinical manifestations of Parkinson's disease. The third important disease that we come across is dementia. Here also what happens is some processes, destructive process, automatic destructive processes going on inside some other areas of the brain, and in which area the particular damage occurs, that will determine the clinical manifestation of that particular dementia. For example, the commonest, as you know, is Alzheimer's disease in that category of degenerative dementias. The damage mainly occurs in the what you call the parietal as well as temporal lobes of the brain. There are different lobes in the brain. You can have a frontal lobe. On either side you can have two parietal lobes, and inferior just above the ear inside you have two temporal lobes, and behind that you have the occipital lobe. So the deficiency of these sort of things occurring, that is degenerative process occurring in Alzheimer's disease, is in the parietal as well as temporal lobes. You can have a frontal with temporal, we call it as frontotemporal dementias, and so many other dementias, but they are not that common as Alzheimer's disease. Now, all patients with deficient memory, you don't label it as Alzheimer's disease or degenerative dementias. The commonest is something else, because you can have some deficiency disorders, especially vitamin D deficiencies, thyroxine, can manifest as dementia, as memory impairment. You can have some stroke situations, multiple strokes, small minute strokes, which manifest as dementia. You can have commonest thing being anxiety, can manifest as a memory impairment, you call it as pseudodementia. So all these situations can manifest as dementia, that is memory impairment. But you have to pinpoint what exactly is the reason of a particular patient manifesting as